We have 30 days. That's it. 30 days before something happens in our solar system that we've never seen before. An object from another star system, moving at impossible speeds, is about to reach Jupiter. And here's what nobody is talking about. It could turn around. It could slingshot back. And if it does, we need to ask ourselves a very uncomfortable question. What if that was always the plan? Right now, somewhere between us and Jupiter, 3I Atlas is racing through our solar system at 58 kilometers per second. To put that in perspective, that's 130,000 miles per hour. At that speed, you could travel from New York to Los Angeles in less than 2 minutes. It's the third confirmed interstellar object we've ever detected. But unlike the others, this one is doing things that don't quite add up. Conversations happening right now in astronomy circles, on forums, and comment sections, they're all focused on one date, March 16th, 2026. That's when 3I Atlas makes its closest approach to Jupiter. But here's what most people are missing. March 16th isn't the date that matters. February 20th is, because that's when the window closes. That's when we'll know if this object is following the laws of physics we understand, or if something else is happening. Let me explain what I mean by that. When 3I Atlas reaches Jupiter in March, it's going to pass right along the edge of what's called Jupiter's hill sphere. Think of it like an invisible boundary, about 53 million kilometers out, where Jupiter's gravity starts to matter as much as the sun's. Most objects from interstellar space, they blow right through. They're moving too fast, carrying too much energy for anything to capture them. And under normal circumstances, that's exactly what 3I Atlas should do. But this is where things get strange. Several independent researchers have been running the numbers, looking at what actually would be required for 3I Atlas to not just pass by Jupiter, but to use it, to slingshot around and come back into the inner solar system. And the conclusion they're reaching is unsettling. It's possible, not with natural physics, but possible. Here's the thing about orbital mechanics that most people don't realize. The strength of a maneuver doesn't matter as much as the timing. A small push applied early can reshape an entire trajectory. Like turning a ship's wheel just 1 degree when you're still far from shore. By the time you reach your destination, you're in a completely different place. The same principle applies here. If 3I Atlas were to slow down by just 1 or 2 kilometers per second, and if that happened far enough away from Jupiter, maybe 150 million kilometers out, the entire encounter changes. Instead of racing past Jupiter on a one-way ticket out of the solar system, it could enter Jupiter's gravitational field at just the right angle, just the right speed, to execute a 180-degree turn and head straight back toward Earth. Now, I know what you're thinking. This is an asteroid or a comet or whatever it is. Natural objects just don't slow down in space. And you'd be right. Except we're not talking about a natural process here. We're talking about propulsion. And before you dismiss that as science fiction, consider what Harvard astrophysicist Avi Loeb has been saying about this object. Loeb is the same scientist who studied Oumuamua, the first interstellar object we detected back in 2017. He suggested then that Oumuamua's unusual acceleration could be evidence of artificial origin. And now he's watching 3I Atlas with the same intensity. Loeb has pointed out something remarkable about this object. Its trajectory through our solar system brought it within close range of Venus, Mars, and Jupiter, all planets in or near the habitable zone of our star, all potential sites for life. But its path took it away from Earth until now. If 3I Atlas were to execute a slingshot maneuver around Jupiter and return inward, Earth would be perfectly positioned in its path. The one major planet it hasn't visited yet. The one planet where we know intelligent life exists. This timing is what keeps astronomers up at night, because working backward from that March 16th encounter, The most efficient window for any course correction falls in late January through mid-February. Right now. These next few weeks, after February 20th or so, the geometry becomes locked in. Any adjustment after that point becomes exponentially more difficult. It's like trying to change lanes after you've already passed the exit. So, what are astronomers actually looking for during this February window? They're watching for small deviations, small, systematic changes in the object's trajectory that can't be explained by natural outgassing or solar radiation pressure. The kind of changes that would show up as smooth, deliberate adjustments in the data. Not random noise, but signal. In orbital mechanics, there are parameters called A2 and A3 that measure non-gravitational accelerations. If those parameters start shifting in ways that suggest sustained thrust, we'll know. And we'll know before March. We'll know in February. Now, let's talk about whether this is even physically possible. Because the energy required to slow down an object moving at 58 kilometers per second is staggering. Researchers have calculated that if 3I Atlas has even a fraction of the mass we think it does, somewhere around 3 billion tons if it's hollow, you'd need enormous amounts of propulsion to decelerate to enough for Jupiter's gravity to matter. Chemical rockets? Forget it. You'd need hundreds of times more fuel than the object weighs. Ion drives? Still not enough. We're talking about over 1 billion tons of propellant. But there is another option. Plasma drives. These aren't science fiction. We're working on them right now. NASA funded research into something called a Vasimir drive that uses superheated plasma accelerated through magnetic fields. With exhaust velocities around 1,000 kilometers per second, suddenly the math changes. Now you're talking about 105 million tons of fuel. Still enormous, but not impossible. And here's what's interesting. 3I Atlas has been shedding mass, a lot of mass. Its tail and anti-tail have been expelling material in quantities that dwarf what we'd expect from a normal comet. If that material could be converted into plasma fuel, you'd have everything you need. But there's even a more efficient possibility. Aerobraking. Dipping into Jupiter's upper atmosphere during the flyby to bleed off speed through friction. The European Space Agency is planning to use this exact technique at Venus. The problem is that at 3I Atlas's current velocity, the heating and deceleration forces would be extreme. We're talking hundreds of Gs, enough to rip most objects apart. Unless the object was designed to withstand it. So I want to be clear about something. I'm not saying this is definitively happening. I'm not even saying it's likely. What I'm saying is the physics allows for it, and the timing is remarkable. Because the moment when 3I Atlas would need to make any course correction, late January through mid-February, is also the moment when Earth-based observation becomes clear enough to detect it. Solar glare decreases. Astrometric uncertainties shrink. The data gets cleaner. If something unusual is happening, this is when we'll see it. There's something else worth considering. If you wanted to study multiple planets in a solar system, and you had the capability to navigate between them, would you do it all in one pass? Or would you take your time? 3I Atlas entered our solar system and made close approaches to Venus, Mars, and Jupiter. It flew past Earth at a distance, but it didn't approach. It observed from afar. If you were an intelligence surveying our solar system, and you detected technological signatures coming from one particular planet, would you approach it immediately? Or would you observe it first, assess it, and then decide whether to make a closer pass on the return trip? I don't know the answer to that, but I know the question matters. Because if 3I Atlas does slow down in February, if it does execute a slingshot around Jupiter in March, we're going to have to confront some very difficult questions about what we're looking at and what it means that it's here. The next 30 days aren't just about watching an interstellar visitor pass through. They're about watching what it does before it reaches Jupiter, whether it stays on its current trajectory, following the cold mathematics of gravity and momentum, or whether those equations start to bend, whether the numbers continue to describe a passive object drifting through our solar system or something else, something with agency, something with a plan. Avi Loeb put it this way: we should approach the universe with scientific openness. We should be willing to consider possibilities that make us uncomfortable, as long as they're grounded in evidence. And the evidence is about to get very interesting. Because by the end of February, the astrometric data will be clear enough to see patterns, to see intention, if it's there. I spent a lot of time looking at the trajectory of this object, the orbital solutions, the velocity calculations, the timing of the Jupiter encounter. What strikes me most isn't the strangeness of it all. It's the precision. Natural processes are messy. They're chaotic. They produce variation. But 3i Atlas has maintained a remarkably stable trajectory since we first detected it. And now it's approaching the one planet in our solar system with enough gravitational power to change everything at exactly the moment when a course correction would be most efficient. Maybe that's coincidence. Maybe the universe is full of objects threading those perfect needles through solar systems without any awareness of what they're doing. But maybe it's not. Maybe we're watching something that knows exactly where it's going. And maybe these next few weeks are the last chance we have to see that knowledge reveal itself. March 16th is when 3i Atlas reaches Jupiter. But February is when we find out if it's coming back. That's the window. That's the timeline that matters. And it's closing faster than people realize. The universe has given us a lot of mysteries over the years. Strange signals, unexplained objects, phenomena we don't fully understand. But this one is different because this time we know exactly when the answer arrives. We know exactly what to watch for. And we know that if the answer is what some researchers suspect, everything changes. So, keep your eyes on the data these next few weeks. Watch for the reports from observatories tracking this object. Because if something shifts, if these orbital parameters start showing substantiated deviation, we're going to know we're not alone. And we're going to know they're watching us just as carefully as we're watching them. The February window is open, but it won't stay that way for long. But that's just what I think. I really want to know what you think. Drop a comment below, please. And if you like what we're doing here, please like, share, and subscribe. It's free for you, and it really does help the channel grow. Be sure to check out all the other links below for cool stuff as well. And remember, always keep an open mind. Not so open your brains fall out. Thanks for watching. I'll see you again soon.